Welcome back one more time. This is lesson 10.6, samples and population. We're on our probability unit. The essential question is how can you determine whether a sample accurately represents a population? Okay, so we've got more vocabulary. Population. Now, you probably think of population of having to do with people, and actually the word pop has to do with Latin for people. But in the case of what we're studying here, it really just means the entire group. Now, it can be people, but it can be objects as well, but it means the entire group. Now, a sample is a part of the population, and you can use a sample to make an inference or conclusion about a population. In one of my previous jobs, I did sample inspecting. The company I worked for, we bought parts, like sheet metal parts or plastic parts from other companies. And we did not inspect them all, but we did what was called a sample inspection. We would pull from the boxes randomly and measure certain, the most like kind of critical dimensions on the objects. We would measure those and make sure that they met the blueprints that we asked the manufacturer to make for us. And if there were too many that did not, then we would reject the entire population, the entire shipment of parts. So that's an example of how sampling works in the real world. In this diagram here, it says identify a population. So in my story, that would have been a shipment of parts. Select a sample. We would pull from different boxes. We would pull from different layers of the boxes, just to make sure we got random sampling. We would take our measurements, so we would interpret the data in the sample. So in other words, we would take our measurements on those sample parts, and then if those parts look good, we would infer that the entire population was good. If those parts were bad, we would infer that the entire population was bad. Okay. Let's take a look at some examples here. Oh, no, sorry, more vocabulary. What was I thinking? Unbiased sample. Okay, it's a representative of a population. It is selected at random and large enough to provide accurate data. So in my story, when we were picking parts to inspect from the boxes, we would pick them from different boxes. If they were stacked up in the boxes, we take some from the top, some from the middle, some from the bottom. We would just open different boxes and take parts out randomly. A bias sample is not representative of a population. One or more parts of the population are favored over others. So in other words, if we took them all out of the top boxes, these boxes came in on pallets. If we just took the ones from the top boxes and those were bad, well, we can't assume that all of them were bad then. Only the ones that were made last or packed last, we don't know. Okay, so let's look at this example here. We want to identify an unbiased sample. You want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? So the first one says 4 students in a hallway. B is all students in the marching band. C is 50 seniors at random, and D is 100 students at random during lunch. Okay. What are you thinking? I want you to think to yourself here, which of these is unbiased? So you want to look for, in the ones that you think are biased, what are your reasons you think they are biased? In the first one, 4 students, it's not enough. That's too small. Now, they don't tell us what the population of the students in high school is, but from the others, we can infer some of the things like 100 students at random during lunch. We can infer there's a lot of them there. All students in the marching band. Well, the marching band is not necessarily representative of the entire school. They have that in common, but a lot of other people don't have that in common with them, so they're not representative based on that. 50 seniors at random. Well, these are all students in the same graduating class. They're together as they're in the same age group. So that's not representative of all the students in a high school. The correct answer here would be D, 100 students at random during lunch. Now, I think this makes some assumptions that we don't know about here, that all students have the same lunchtime, but that may not be true. Bigger high schools, lunches are kind of split. Like even at our school, we split lunches because of trying to make sure all the kids can get through lunch and in a quick amount of time. We have to split lunches into 2 periods. But you don't even know about that maybe because you haven't been at our school because of the pandemic. Anyways, the answer here is D. So take a look at this one. What do you think about this? You want to know the number of students in your classroom who do their homework right after school. You survey the first 10 students who arrive in the classroom. So A, what is the population? B, what is the sample? And C, is the sample unbiased? Okay, so answer those 3 questions and then join me on the next screen. Next, we want to determine if we can, we want to see if we can determine whether or not conclusions are valid. So let's take a look at this problem. You want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. So A, you survey the 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude that 75% of your residents of your town support the new sign. Is that a valid conclusion? What are you thinking? What are you thinking? What are you thinking? It is not. By choosing your sample to be the 20 residents who live closest to the new sign, they're more affected by the sign. Now, maybe you're thinking that their opinions should have a little more sway. They should have a little more effect on the decisions because they live closest to it, but that's not what you're trying to determine. You're trying to determine how the residents of your town, right? Not the ones closest to the sign. So this is not valid. The sample does not represent the population. Okay, again, by the 20 who live closest to the sign could have a different opinion because they're more affected by the sign. Look at B. You survey 100 residents at random. See, that's an important thing. It's at random. 40 support the new sign and 60 do not. So you conclude that 40% of the residents of your town support the sign. So this one is a valid conclusion because the sample was done at random. Excuse my writing. At random. Yeah, the sample was done at random. So in this case, the conclusion is valid. 40% of the residents will support the sign. Okay. And let's take a look at example 3 here. Making predictions. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number N of students in the school who watch 1 movie each week. Okay, so for this, we're going to revisit our friend, the proportion. So 1 movie, 21 kids out of 75. We're going to set that equal to N over 1,200, the total number of students in the school. Okay, and I think for this, we're going to use cross multiplying. So 21 times 1,200 and 75 times N. So 21 times 1,200. $25,200. That's going to be equal to 75 times n. So dividing both sides by 75. $336 equals n. So our prediction is 336 students out of the 1,200 at the school watch one movie each week. Okay, that's it for this video. Oh, we're moving right along. It's so good to feel like we're getting so close to the end. Thanks a lot, and I'll see you in class. Bye-bye.